In this video, I am going to show you how to use the lens equation calculator to solve quantitative type problems for lenses that involve solving for DI. So what you see here is basically the solve part of a quantitative type problem. Step one, list the equations. You have the lens equation here, the variables for each one of those terms in the equation, and then the solve part. I'm going to break the solve part up into 3 subparts so you can see what I'm doing a little more easily. What you see down here are little boxes with some equations in them. You don't need this for the calculator. This is just show you each of the steps as I work through the problem. So in the calculator, what I can do is I can type in numbers for the focal length of this lens and the distance the object is from the lens. This will work for convex and concave. You just have to type in negative quantities for focal lengths for concave lenses as opposed to positive values. So in the solution part, you can see here when I substitute the values in, the 5 is going to go in for F for the focal length, 3 is going to go in for the DO. So I have this equation, which if you convert these to decimal numbers, it's 0.2 and 0.33. So I'm going to write my first equation. I'm going to say this is going to equal, this cell right here is going to equal 1 divided by that 5 sitting there, which should be 0.2. And in the next box, I'm going to type equal sign. That starts the equation. 1 divided by that 3. So there's my 0.33, corresponding to the 0.2 and 0.33. The negative 0.133 is by bringing over the 0.33 to the other side of the equation. So I'll write that here. This is going to equal the 0.2 minus the 0.33. There's my negative 0.133, which you see here. And of course, that's 1 over di. So to solve for di, I have to cross multiply, or basically say 1 divided by negative 0.133. So I'll do that. This cell is going to equal 1 divided by that answer I just solved for, which gives me the negative 7.5. This cell here shows the answer because I simply made it, if you look here, equal to the cell G16, which is where my answer was calculated. So you can see here that I have a negative di, so it's a negative, so it's a virtual image, which makes sense. If I put an object within the focal point of a convex lens, I should get a virtual image. But the nice thing about this calculator is I can change the focal length d zeros to get different answers. So if my focal length were 7, I get a different answer. It appears there automatically. Basically because these equations depend on the values I input, and the answer depends on the numbers from those equations, so it's automatically updated. If I put an object at the focal point, we know that's not good. We won't see an image, and I get a divide by 0 situation. But if I put it outside the focal point, I can see I get a real image, plus 16.8. And again, so I can change the focal length here. I can change it again. And every time I do that, you can see that the answers change. So that's a introduction to the use of the lens equation calculator for lenses.